Danfoss Power Solutions, a company that creates hydraulic pumps and motors for off-highway equipment. We worked with their H1 large frame line, which is a high variability line that produces over 200 unique products. It is expected that their demand will be increasing in January of 2020, and that in order to be able to meet that expected demand, they'll have to increase their throughput from 50 units a day to 80 units per day. They will also have to increase their efficiency from 54% to 65.8%. For the current state analysis, we took time studies to validate the cycle times for each of the units, and we concluded that production was 50 units per day. We also were able to identify that the bottleneck of line was Station 60, the test stand, and that the second longest cycle time was at Station 50B, the air decay test.
While taking time studies, we observed variability of the number of operators staffed on the line and the work content allocated to the operators.
A Simio model of the current state was developed to serve as a precursor for the future state model. Data was mined over the last year to date to try to source where a majority of the downtime was occurring.
Additional time studies were taken at the bottleneck, which resulted in us identifying that a lot of idle time was there due to operators not identifying when the tests were over. This led to the recommendation that an and-on light be installed. It was also identified that skewed fittings often created a severe leak in the air decay test. This led to the suggestion that new quick connect fittings with tighter tolerances be implemented.
Another issue we saw on air decay was the operators were forgetting to put all the fittings on the pump, and we recommend installing a pick-to-light system to fix that. Between air decay and test stand, there are 2 hoist adapters used, and we recommend consolidating that down to just the specialized one. Using the time studies, we created 2 variable staffing plans for this line.
These staffing plans will optimize efficiency as well as solidify the work content allocated to each worker. Operators refuse to use the hoist at the end cap station on account of it being held by a small magnet. If they don't wait for the hoist to stop swinging, it becomes detached with the potential of hitting them in the head. Our recommendation for this is to have a custom tool holder made in the fabrication shop. Servo cans are put in early on in the process, and adjustments are required to be made throughout the assembly process. This is currently done by hand. We recommend implementing an electronic torque gun to standardize this process. This will not only reduce the amount of cycle time needed to balance the unit, but will also reduce the amount of adjustments needed on the test stand. The scanners on the current line are very outdated and take an excessive amount of time to get an accurate scan. We recommended updating the scanners for both shavs and HPRVs. These recommendations have already been implemented and are functioning much more efficiently. A future state Simio model has also been developed. All of the ideas mentioned previously, as well as an additional test stand, have been implemented to simulate our future state design. This will increase our throughput by approximately 23 units per day. Assuming Danfoss implements all of these changes, they will see approximately a $3.7 million return on investment over the next 3 years.